Okay. I'm not really sure where to start. Something happened, and I'm not sure whether to get started with the lesson or just tell you what happened. Hmm. You might not believe if I say what I'm about to do now is a repeat of what I've just done. Uh, hmm. I'm not sure whether to tell you now or tell you in the end. But honorable member, I'm going to just do what I've already done. Look at this. Look at this. You see from there, all of this, honorable member, all of this, all of this, all of this, all of this. I've just done it now, but guess what? My screen was not sharing. My screen was not sharing, but I was live. So that means I spent the whole 1 hour teaching myself or speaking to myself because my screen was not sharing. So that means I have to redo it now. I have to redo exactly what I've just done now. And I think it was almost an hour long lesson. So I think it's worth it for me to tell you to say it is such mistakes that will cost you a lot. In real life, in an exam, it could be a test, whatever the case may be. So you just need to make sure that whatever that you do, you pay maximum attention. Because if you don't, imagine you record, but your screen is not sharing, or it is sharing and you're not live. It's those type of things that will drag you back, honorable member. But if you somehow find a way to say, for me to eliminate making a mistake, let me just make it or do a checkbox whereby every time when I record, I'm going to have a checkbox to say screen sharing, live, and then action. You see? So yeah, I think it was worth it for me to mention. And you might not believe if I say in that same lesson, I made a joke to say, imagine that situation where you are responding to a friend who has just made a joke and you want to record yourself laughing and all of that, and you try to laugh, not even trying, but you laugh because yeah, it's that much funny. And when you're about to send, you realize, no. This thing, it wasn't recording. And then now you have to try re-laugh and all of that. So this is me now. I was laughing. It didn't record. Now I have to laugh. Okay, so this are honorable members. This is what we are going to be talking about in the lesson for today. Whereby, when you talk about the Surds, just be aware that when a root is irrational, it is therefore referred to as a Surd. Very much important on that one. In other words, a Surd, it is the root of a number that cannot be determined exactly. I'll give you an example to say, when you say square root of 2, you see, another example, it would be square root of 5. Not only that, but also, even if you say that square root of 20. So these are the surds. It will only make sense when I give you the examples which are not the surds. For example, when you say square root of 4, this one, it can be determined, it is the same as 4. And then now, what else? If you say square root of, did I say square root of 4 is 4? It's supposed to be 2. I'm not sure what I said, but it's fine. Square root of 36, definitely that one is 6. We know most. So even if you punch 3 and then you are having that cube root of 27, it will definitely give you a number there. Let me quickly verify. If you say shift that and then you say 3 there inside the brackets, you say 27. Yes, it gives you 3. So can you see? But this one, if you punch it on a calculator, it gives you that. That is the difference, honorable members. Same as that, or you convert it, it gives you a decimal. So, okay, I just wanted to make you aware of that. Most importantly, we only have two main important laws when it comes to the surds. Law number 1, talks about a multiplication. So here we are talking about the multiplication law. That is the type of a law that we are going to be exploring and be talking about. Whereby um, hmm, something that you need to remember before I even explain these laws. Just remember that when you have a square root, it could be 2 there. You always have invisible 2 there, always, unless if they write a number there. So that means this thing, it is actually the same as 2 square root of 2. Just be careful of that. Just like x, it is the same as or equals to invisible 1x. Same principle there. Okay, so now let me get to the law. So the law will therefore say if you have whatever that you are having there, which could be invisible 2 or whatever number, nay. And then inside the square root, you have base A. Again, you have that exactly that same thing. And then, but here you have B. The law says you can therefore write this thing as whatever that you are having there. But now, because you are multiplying those square roots, you also multiply those bases. And this thing on its own, it is a law, and it is referred to as a multiplication law, which means, honorable member, it can be given to you in this format. Therefore, you will therefore convert it to that format when necessary. Again, it can be given to you in that format. Then you can take it back to that. So whatever that you are given, you can do the forward and the reverse application. It just depends on the nature of the problem. So now let's look at law number 2 being the last law that we are having, and this one, it is the division law. The division law. Okay. So when it comes to the division law, not that much complicated. Again, we are having that and then the base being A. Definitely, we will have to divide because it's a division law. Then we are having n square root of a different base being base B. So easy. You are just having now that dividing with that. That's how we are going to be applying the division law. Again, maybe given you in that format where you need to now rewrite it in that format as you simplify, or whatever the case may be, or be given to you like that, then you have to take it back to that. Trust me when I say it will make more sense as we do some examples. So now let's see. So these laws, they apply in these conditions whereby the A value, it is more than 0 or greater than 0. And again, the B value greater than 0. So that means you can't have that A being 0 or negative number. 0 or negative number, 0 or negative number. They will all be greater than 0. It would rather be 1 or something of that nature. Even 1/2. 1/2 is obviously half. It's greater than 0. Most importantly, the value of n, you see that one, it is either it is more or equals to 2. So it can't be less than 2. So that means it will never be 1 there, because as I've indicated, if it is square root of 2, for example, already the number which is invisible there, it is 2. So just be careful of that one. Very much important. And lastly, we will therefore say the n values are actually the element of natural numbers. So Out of all that I've explained, what matters the most, it is those two laws, the multiplication law and the division law. This information that I've just explained now, even if you do not know, you will still survive. So now, without wasting much of our precious time, definitely let's get into some examples and apply these laws. What an interesting experience having to redo something that I've already done. Yo. Okay. 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 Then it's fine. It's fine. It's fine. So now let's see. Um, This is what we are having as our first example that we are going to be looking at. Let's say you are given square root of 2 multiplying square root of 3. The question itself says simplify the following. Definitely, the moment you see that you are given a math problem and you don't have an equal sign, it will therefore mean you are dealing with what is it? It will therefore mean you are dealing with an expression. And where you have an expression, it means you will definitely need to simplify, which is exactly what I'm going to be doing now. So now let's see. It looks like when we apply the law of multiplication, it says this and that, those spaces, they are just going to multiply each other. And then that times that is 6. Definitely, we end up having 6 as our final answer there. Then let's jump on to another example where we may be given square root of 3, that is multiplying square root of 3. Definitely, one square root, you multiply the inside bases, then you end up having square root of 9. But square root of 9 is 3 most. Yes. So that should be the end of it. Okay, so let's do another one whereby let's say you have inside the bracket square root of 4 and then we square. What I know is that square means two of exactly the same thing, two of exactly that. So it's like you are having square root of 4 that is multiplying square root of 4. That's exactly what you are having, whereby now you can multiply those things inside and you end up having square root of 16, but we know more. Square root of 16 is the same as 4, isn't it? Yes. Yes, 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 yes. Alternatively, this can be worked out as, remember we have invisible 2 there. So it's like you are having that 4, and then here you have invisible 1. The 1 becomes the numerator, and then over 2 there, and then you still have your 2 there on the outside, whereby this multiplies half. It's like you have 4 to the exponent of 2 over 2, and then that cancels that and that, and you end up having 4. So you've got multiple choice. Can you see? It just depends on the approach that you prefer. Okay, maybe let's be fair and look at another example where now we are having some fractions. Let's say we have square root of 27. And then that square root of 27, let's maybe divide it by square root of 3. Yes. Let's maybe divide it by square root of 3. Then from there, let's see, what are we therefore going to do there? I think, let's see, that 27, but that 27 and that 3, there, since we are dividing, let's apply that law, honorable member, where we will therefore have that 27 that we divided by 3. Then we are therefore going to have square. What is this divided by that? Let's see. 27 divided by 3. It's 9. Yes. But wait, isn't square root of 9 equals to 3? Hmm? Square root of 9 is equals to 3, isn't it? Then it means this should be the end of it. I hope that part makes sense. Okay, let's maybe in addition to that, do this one. Let's maybe do this one where we have that, and then here, let's say we are having 16, and then again having 3, and then that. Let's say we are having 2 there. Yes. Yes, 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 yes. With us having that, maybe let me not continue with it there. But let's have it here and say so that means since we are having the same thing there, 3, 3, then we have 1, 3 there. Most importantly, we will be having that 16 divided by 2. Can you see we've just applied that law? And then 16 divided by that, definitely that is 8. That is 8. But 8 can be written as a power, which means 8, 8 can be written as what? Is it 2 to the 3? I think 2 to the 3. It is the one which is 8. Yes. Whereby what we are therefore going to do, we end up having this 2, that 3, it goes to the numerator, and then that 1, it becomes the denominators, always like that, where that will cancel with that, and then you end up having 2. And that is the end of it. So we've just applied the multiplication and division of Surds. We've just applied those 2 laws, honorable member. So now I think I will just end it here. And then on the next lesson, we will be looking at the addition and subtraction of the Surds. Okay, let me just leave it here and say until we meet again. Let's see. Yes, the screen sharing, and yes, it was recording. Yo, I no longer want a repeat of what happened.